The first page in the Transition Metals Notes pack looks at the electron configuration of both the elements and their ions. I'm not going to go through the whole of this page writing electron configurations out, so I'm just going to focus on one particular element. So let's have a look at vanadium. So you'll see from the periodic table that vanadium has an atomic number of 23, which means it has 23 electrons. Let's write its electron configuration. So we have 1s2, 2s2, 2p6, 3s2, 3p6. Then we go into the 4s, so that's 4s2. Let's count how many electrons we've got so far. So that's 2, 4, 10, 12, 18, 20. So 20 electrons so far, so we need 3 more, and they're in the 3D. So that's 3D3. When we write these down, we'd normally put the 3's all together, so let's put the 3D's next to the 3P's. So that's how we would quote the full electron configuration for vanadium. Here we're asking us to think about the shorthand version as well. So we go back to the previous inert gas core, which for vanadium will go back to argon. Argon had 18 electrons, so that's the electron configuration for argon. So everything I've just highlighted in green there is the same as argon, so we put that in square brackets, and so the shorthand for vanadium is simply argon in square brackets 3d3 4s2. Moving on to the ions, so for the 2+ ion, that means we want to lose 2 electrons, and the benefit of writing out the 3D before the 4s is it will remind us that we want to lose from the 4s first, which means for the 2+ ion, the electrons which go first are the 4s, and there's 2 electrons in the 4s, so the electron configuration for the vanadium 2+ ion will be that inert gas argon core, so 1s2, 2s2, 2p6, 3s2, 3p6 if you're writing it out in full, and then just the 3d3. For the 3+ ion, here we want to obviously lose 3 electrons, so we're going to lose the 4s2 again, then we move into the 3d, and we're going to lose one of those 3d electrons. So here the electron configuration is the inert gas core, the argon, and then 3d2.